Good day, listeners. Today we're going to talk about an interesting topic. We are looking at a preterm analysis. What do we mean by preterm analysis? We got this data from Kaggle. We urge you to visit kaggle.com. You can search for that data, preterm analysis data set. So with that data set, we were able to use it to do our preterm analysis. So what we're actually focusing on is that we are trying to make sure we get the actual meaning, the cause, and the effect as a result of preterm birth. The term preterm means born or occurring after a pregnancy, significantly as a shorter than more normal a special period of time which pregnancy or birth ought to have taken place or occur. Okay, as the terminology means preterm. Okay, preterm. So it therefore means that before the actual time. Okay, we have observed that a lot of persons or pregnant women are passing through miscarriages, and as a result of there could be some contributing factors. All right, so on this data set that we are using, we are going to use it to analyze the cause and the effect. Okay, the reason why preterm is occurring. Okay, the reason why some pregnant women are facing this kind of challenges. So with this data set, it will enable us to unveil the hidden patterns and also make a meaningful contribution or a better decision for future purpose. All right, so very quickly we are going to import some libraries that we'll be using today. Okay, we're going to import numpy as np. We're going to import pandas. Okay, pandas as pd. We're also going to import scikit-learn, sklearn. All right, import sklearn. All right, dot model dot underscore selection. All right, so we're going to import sklearn.model_selection. So we're going to use this one for model selection. Then after which we're going to talked about importing import sklearn.model selection as train underscore test underscore split. All right, something like this. I think for now we still need to receive from sklearn. Okay, from sklearn underscore sklearn.model. You can see from sklearn.linear. Okay, dot linear underscore model. You can as well import then import a linear regression. Import linear regression. All right, linear regression. So we're going to use this. So these are the few libraries we are going to import for now. So let's run it and see how it looks. So if there's no any error, we're going to continue and proceed on the next stage on how we can do it better. Now first, very quickly, we are seeing some error here. You say from sklearn.linear model. Okay, from sklearn, sorry, it's supposed to be from sklearn, and I say as. Okay, from sklearn.model underscore selection. Import train test split. Also have a from sklearn.linear underscore model. Import a linear regression. Okay, sklearn LEARN, that is how it should be, dot linear underscore model. Linear is LE. Okay, we misspell. It should be A here. Okay, I think this is the right spelling. Now we have gotten this. These are the 4 libraries we'll be using for now. As time, we can as well import what is called from let's say from sklearn. We can as well import let's import what is called matrix. Okay, now very quickly we are going to call our data. So let's say pd.read underscore csv. This is the data we are going to use. All right, now this data is located somewhere here. Okay, now we are getting this data already. If I say data dot head, let's see how the data looks like. Good, these are the data we are working on. I'm going to zoom out so that you can see this very well. Now if you look at this data, we have count, the number of count of contraction, we have length of construction, we also have our STD, which is sexual transmitted disease, we have the entropy values, we have the contraction time, number of contraction time, and we have preterm. Okay, when the value of preterm is 1, that means there is occurrence, there's every probability that, there's every tendency that preterm will occur. If it is 0, there's no what occurrence of what preterm. So that is the interpretation of this data very quickly. Now since we've gotten that, what I want us to look at is this, because if you come here now, if we say data dot tail like this to see the last value, you see that we have zeros here as the number proceeds starting from 53 down to the last. Okay, we have zeros. Okay, now that we've gotten that, if I say data, let's see that the descriptive statistics here, data dot describe, sorry, if we check this, good, these are the descriptive statistics. We have the count, we have the mean, we have the standard deviation, the mean 25 percentile, 50th percentile, and 75 percentile, and the maximum value of all of this whole thing. Now that we've gotten that, next let's go straight to the, let's know the shape of this data. If I say data dot what shape, all right, I will come here. If I come data dot shape, sorry, we have 58 rows of data and 8 columns. All right, and if you look at it, you have 57 here plus 0. That is what the first row is counted as what 0. So the total of all the row of this data, we have 58, and the column is what 6 column. Now that we've gotten that, let's move straight to what training of and testing of this data. Now what I want us to do is this. I'm going to come here very quickly and ask data dot columns. You see the columns of all the data we are working on. Look at it here. Now after that, we are going to come and say train equals to data dot drop. We have to drop some values here. And what are we dropping? Using the drop function, we are going to drop some column, and some column will be dropped. So first we are going to drop contraction. Okay, we are going to drop length of contraction as well. We are also going to drop STD as part of chain data. We're also going to add the entropy to it. Then we also have to add the contraction time to it. Then after which we're going to stop there. Then the rest will be for what? Testing data. Now if we have that as our train data, then our test data will now equals to data dot, very quickly we'll just say data dot what, put it into what, a square bracket, add our what, preterm value. Preterm is our what, test data. If I run this code, you see that there is no error. Okay, if it display without error, we are good to go. Let's see the reason why we are getting this error. You see this. Okay, all right. Okay, now we are doing that. After that, I'm going to come here. We say as is. Let's set as is. Let's set the as is to 0 or 1. Let's set it to 1. Okay, I think the error will go now. All right, now fine. Now we have done that. Now say x underscore text. If you say x text, comma, x underscore train, comma, also have x underscore what, and how many of them should we get? We have s stress, s thing. We should have what, y text, and also we should have what, y underscore what, train. All right, all this we are going to say equal to, we're going to use the train underscore train underscore test split. We'll set it to this. Then we'll put train data set. Then we'll call out our test data set. then we'll now set our what? Test size. Okay, the test size, we say we are testing 30%. Okay, we are testing 30% of this data. So by so doing, I will now say 0.3, and then the remaining 70% is going to be trained data set. But let's set the random to what? To random state. If I run this code, no error, we are good to go. Now that we've gotten that, I'm going to come here because we need one library. We are going to use a support vector machine in this training as our machine, as the machine learning algorithm. So we're going to import support vector machine here. Now to do that, I'm going to say from sklearn import svm. All right. Now that we have imported support vector machine, let's generate a model here. To generate a model, I'll come here and say CLS is a variable name. Okay, I'm going to say svm dot svc. Okay, now we are calling this a model. Then by so doing, we'll set a kernel. Okay, we're going to set a kernel. I'll say set a kernel to linear. All right, we are setting this kernel to linear. Now that we run this code, no error, then we'll proceed by so okay. Next, we are going to what? Fit this our model to our trained data set and our test to our trained data set, which is X and Y train. So to do that, I'm going to come here and say CLS dot fit. Fit is a function that we are going to come here and say X underscore train. All right, S underscore train, comma Y underscore what? Y underscore train as well. So we're going to call this two. If we fit this data, you see, good. It's saying that support vector, this has been what? Fits successfully. Now what I'm going to do next is to come here. Let's call our prediction value, and that's okay. Call a pred. Define a variable, call it pred, and that's a predict. We're going to say okay, CLS dot predict, which is a function, and what we are predicting here is our X text. Okay, we are predicting this our X text. If I come here and I say call this variable pred, you see the predicted value. Here there's no preterm, here there is preterm, no preterm, no preterm, no, here there is preterm, no preterm, there is preterm, there's every probability there will be preterm at interval of what? 3 occurrences. Maximum of 3 what? Occurrences. Even here at this point, we even have no preterm, which is 1, 2, 3, 4, 5, 6, 7. You will have at interval of what? 8 occurrences. There's every probability that at interval of 8 occurrences there will be what? Preterm. Okay, of occurrence. Okay, now we are going to come here. Now that we have gotten the value of our what? Predicted value, I'm going to come here and say let's print the accuracy level of this data. I'm going to come here and say accuracy, all right, level. All right, I'm going to come here. Now this is where I'm going to use my matrix that we have imported last time, because I now say accuracy score. Then we are going to pass it to Y text. All right, now if we run this data, I can say my Y test, let it be equals to what? Y test to what? Pred. Okay, we can call our predicted value to it. Now if you look at the accuracy level, we are having what? 1. Okay, which is 100%, very strong level of what? Accuracy. Okay, now we are going to move further to say okay, let's check the confusion matrix. I'm going to come here and I say print confusion matrix. All right, print the confusion matrix. I'm going to check the confusion matrix. By so doing, I'm going to come here as a value. I'm going to print it. Let it show in this format. I'm going to say matrix dot pair confusion matrix, like this. Okay, we are going to get the pair confusion matrix, and we are going to set it to Y underscore test. All right, Y underscore text to, let's say Y underscore test, comma Y underscore pred. Okay, because we already at this point we already set a value that we have Y pred. Okay, if we have y test, okay, we can as well say, okay, let's get a value here. By so doing, I can say, okay, we have y test. I can say y underscore pred equals to what? The predicted value. If we run this, we are seeing error. Let's see the reason why we are seeing this error. Okay, it said that missing requirement labels pred. Okay, all right, now let's look at it. Y underscore pred. Okay, we have y test, comma, okay, y pred equals to pred. Okay, if we are to do that, why don't we just run this code like this? Good, let's not set up all those variables. Now this is our confusion matrix. We have 728 as 0 as here. We have 0 to 0 by, this is 2 by 2 matrix. Okay, this is our display of our what? Confusion matrix. Now if we have gotten that, let's check the precision of this data. Let's get the precision. Let me comment here, precision. All right, to get the precision, I'm going to say print precision. All right, print the precision here. All right, now we are going to come here and now come and say, okay, get precision. That's a matrix. Okay, dot precision, matrix dot precision underscore score. If we get this, let's see how the precision look like, and we are setting it to what? Y underscore text. Okay, after which we now say, okay, get the predicted value. All right, let's see why we are getting this. Matrix is supposed to be RICX in this format. The precision is also what? 1.0. Good. In correlation, we can say there's a strong correlation here. All right, at a positive word direction. Now very quickly we can move further. Let's look at the model accuracy. Okay, let's look at the model accuracy, whereby we can see the precision score, the recall, the F1 score, and the supported values. To do that, I'm going to come here. I'm going to write a comment. Okay, I'm going to write a comment here very quickly. The comment, I'm going to come here and say, okay, model accuracy using a SVM. All right, now I'm going to come here. Now what I'm going to do, I'm going to print some value here. Print recall. All right, and the recall value is going to look like this, after which I'm now going to say matrix. All right, underscore matrix underscore recall. All right, underscore score. If we get this value, and we're going to pass it to what? Y text, and also we're going to pass it to what? The predicted value as well. Now that we've gotten that, next we are going to come and print empty value here to create a space. Then we'll now come here and ask, okay, print matrix dot classification report. All right, classification report. This will give us the report of what? The what? Data. Y underscore text. We'll pass it to this Y underscore text, and also pass it to what? Predicted value. Now we have seen this. It's a matrix. Name matrix recall is not defined. Now let's look at it. Matrix. If we just say this, I think there's a wrong spelling here. Classification report. Classification report. All right. Now we're having this here. It's a recall. Matrix recall. Yes. Yes, supposed to be matrix dot recall. All right, good. You're supposed to say matrix dot recall, not underscore, recall underscore. Okay, now look at it. The recall value, like we already know, we have 1.0, and these are the what? The reclassification report. If you look at it, the accuracy level here, we are also having what? 100% level of accuracy at a very strong positive direction. So this is the recall value, and this is our classification report. Very quickly, let's use the heat map to show what interaction each and every one of these column or data have with each other. What effect does one data has with another what? Data. Okay, now by so doing, we are going to use this heat map to interpret this data properly, because map or graph or visualization give a pictorial view or a detailed explanation where to interpret the data more accurately rather than using figure. Using graph or visualization will depict the data interpretation more properly. So to do that, we are going to come here. I'm going to import matplot lib.pyplot as plt. Okay, because we're going to use a matplot library. Then after which, I'm also going to import cbon. Import cbon as SNS. Alright, these are the two libraries we have imported, and we're going to make use of them. Very quickly, I'm going to come here and say, okay, plt dot title. We're going to title this. I'm going to call it a observation or observed correlation. Observed correlation in different data sets. All right, that is the data title, the graph title. Well, that's okay. SN dot heat map. We're going to use heat map. We are passing it to our data, which is our variable, like we know. Dot core. We are calling the correlation value. Since we are using correlation, we are now going to come here and say annotate this data by using the annotate keywords. By using the annote, okay, we set the annote to what? To true. We should annotate it for us. Then we'll also okay, annotate keywords as well, which is KWS. We'll also okay, set it to be what? By size. And that's okay. Let's say size. Alright, and the size should be what? 11. Alright, now that we've done that, next I'm going to do here is to come as a plt dot extict. Okay, this extict, we are going to set the font size. That's okay, font size, set it to what? 14 or 16, as the case may be. That's a plt as okay, y sticked. Let's also set the font size to what? 16 as well. Now that we've done that, very quickly I will now say plt dot what show. Let's see this graph, how it looks. Okay, as plt. Okay, sorry, we are supposed to import it as plt, then run this data. Let's see how our graph looks like. Good. Let's see. Let me zoom out small so that you can see it clearly. All right, now if you look at this data, you will see that there is a strong correlation here. Now what I want to do is this. To do this, I'm going to do something here very quickly. What I'm going to do here is going to be very, look at this. I'm going to come here. Let me say plt dot just say figure. I will set the fixed size to be equals to, let's use a 13 or 10 by 30. Let's use 10 by 30 as the fixed size implies. Okay, now this is the data. Now look at this data very quickly. What I'm observing here, or what I observe here, is that if you look at this data where we use annotate and annotate keywords, we set it to 11. If I turn it to what? 2 or 1. Okay, good. Now I'm going to set it to what? Let's say 90. Good. Now the essence of that annotate keywords is to what? Show us what? The keywords inside each and every one of this graph. Now look at this place here. If you look at the row where we have STD, the darker the background, more effect is being exercised in that heat map. More emphasis or more light is being thrown, or more action is taking place in that particular what? Background. So the darker here you now observe that at this column row, we also have a STD having a darker what value. Okay? Now, if you look at it here, at which point do they meet? We have preterm in this row and STD on this row, and they meet at this point. It therefore means that sexual transmission disease has 38% contribution to what preterm occurrence. Okay, at the row value as well, you see that STD on this row, look at preterm, count it at the point where they meet. You see that sexual transmission disease or transmitted disease has 97% contributing factor to what occurrence of preterm birth. So how can we now see that? You cannot see that infection, most cases are the data or our interpretation have proved that what causes this preterm birth is as a result of what? Infection, which is what? STD. It could be what? Staphylococcus, it could be syphilis, it could be anything. It could be gonorrhea. So 79% from the downward to the upward, and also yeah, we have 38% from the row down to the what? Bottom. You see, this is a real life scenario. See the essence of using a graph or using a visualization. It gives us what? And depict the interpretation more and give us more better understanding. So we can now conclusively say that 75% of preterm occurrence is as a result of what? Sexual transmitted disease. So far so good. This is how far we can go. I want you to contribute on the comment section. If you have any suggestion, don't feel free to suggest. If you like this video, don't forget to share, don't forget to comment, and don't forget to like the video. Thank you. I remain your friend. Good day.